Hi everyone, my name is Tony Liu, and today I'll be presenting our joint work titled Machine Learning for Relationship Estimation, Considering Population Heterogeneity. So why do we want to predict social relationships? Well, these relationships, communicating with friends, family members, and so on, are sort of central to human life and well-being, and disruptions in social relationships have been associated with an increased risk in mood disorders. In addition, the type of relationships individuals engage with can be indicators of the amount of social support that they might receive. So one of the goals of our study is to predict these social relationships from passive phone data. In addition, we also explore age variation and how this interacts with communication patterns within our sample. So participants in our study installed a mobile phone sensing app on their personal devices that collected both passive phone data and administered EMA surveys. These surveys asked about the type of contacts people are calling or texting, as well as what we call semantic location. This is taking locations that the app has detected participants being present at throughout the day and giving them some sort of semantic meaning. So what we have pictured here in the screenshot is a marker of a movie theater that the participant visited, an example, which is given the semantic label of a place of entertainment. So why might this semantic location information be useful in predicting relationship roles? Well, we thought that communication from different contexts could be contextualized through this location information. For example, a call from a bar might provide a different signal to the relationship type than a call from a grocery store. The call from a bar might be a friend, while the call from the grocery store might more likely be a family member. So visualizing this data, what we have here is 4 weeks of location logs for a representative participant. We can see that there is sort of regularity in the locations that they visit, such as a home to work pattern that we would typically see. We then combine this location data with our communication events, with the dots representing the different kind of contacts that this person is talking to or texting. These contact labels are the target for our relationship prediction task. We can see with this visualization that there are some patterns emerging, such as the tendency for this participant to make task-related communications at home, indicated by the blue dots, and the tendency for this participant to make friend-related communications at work, indicated by these pink dots. So our final features for relationship prediction include demographics, such as age and gender, communication information, such as texting frequency and call duration, as well as location information that we just discussed. So let's look at some results. Throughout the study, we used AutoML, which automates both hyperparameter tuning and ensemble selection. We run AutoML across different combinations of all of our feature sets that we just discussed. And one key takeaway here is that including location data improves the performance of our models. We see that models trained with location information alongside the other feature blocks gives us the highest F1 scores. Another takeaway here is that age and gender potentially interacts with communication. The model that's trained only with age and gender doesn't actually do any better than baseline, but age and gender, when combined with communication features, give us a performance boost over the model that just uses communication features alone. This interaction between demographics and communication led us to explore age heterogeneity in our sample. What we found is that as age increases, there is a general preference for calling over texting, as well as a general decrease in late-night communication. Though these findings don't really seem that surprising, what's interesting is that there are differences across relationship roles when we look at age and communication together. So what we have pictured here is late-night texting frequency on the y-axis, participant age on the x-axis. And though the overall trend is that older individuals text less frequently at night, as you would expect, this trend varies depending on the type of contact. We see on the left-hand plot that text to family members are actually relatively stable within our sample beyond the age of 30, whereas texts to task-related contacts on the right falls off quite severely. This again shows that there is heterogeneity in communication across both age and contact types within our sample population, something to keep in mind for us when we were building our predictive models. In fact, when you look at our paper, we performed another prediction task where we trained models on subsets of our population split by age to see how well they generalize to other age groups. And what we found with this exercise is that models trained on younger individuals generalize particularly poorly to older individuals. So what are the takeaways from our work? The first is that contextualizing communication with location data improves performance. And the second broader takeaway is that phone sensing studies should be validated on more diverse samples. Here we have examined how age interacts with communication, but there are other sources of variation in these studies that need to be considered as well, such as employment status, baseline mental illness, and so on. We know that a lot of these studies are limited in participant recruitment for practical reasons, and in fact, our group does a lot of convenience sampling as well, but it's particularly important to keep in mind that building predictive models on these more uniform samples doesn't necessarily translate to generalizability to the wider population. Thank you for your time, and I'm looking forward to any questions and discussion.